Hello everyone, welcome to Recitation Week 10 for Fluid Mechanics. This week we will have 6 different questions and they are most related to energy equation. So let's get started with the first one. This is question 7.16. Here we need to determine the discharge in the pipe and the pressure at point B. We are going to neglect head losses and we will assume a coefficient as 1 at all locations. So let's see what question asks. The first one is discharge in the pipe. So we are going to find the flow rate here. So it will be the discharge from this pipe system. And the next question is pressure at this point, which is point B. So we will frequently apply energy equation. So it is pressure over specific weight times V1 square 2G plus Z1, which is the elevation of the point. Then this is equal to P2 over gamma, which is specific weight again, V2 square over 2G plus Z2. So here we can take our reference points as water surface here and also this point, because eventually we will need to find discharge here. And since we can find some values related to this point, we can directly take these points as the reference, as the energy equation. So let me say this is point 1 and this is point 2. So first of all, we will not have pressure term at point 1 because this is open atmosphere, so that we can assume a zero pressure here. Additionally, we will not have velocity here because you can think this as a large tank and our reference point is the surface of this tank. So there will be some minor velocity here. But since this is mostly fixed, we can neglect the velocity, so we can take 0 as the velocity here. And Z1 will be the elevation of this location. And here we can take this level as the reference, so that Z2 will be 0 and Z1 will be 5 meters. So we have 5 here. On the right hand side, again we have P2, and again we have atmospheric pressure, so opening the atmosphere, so we can also assume this is 0. We will have V2 square over 2G. This time we have velocity because the water will be leaving this pipe with a velocity. And lastly, since we took that point as reference, the Z2 will be 0. So Vt square will be equal to 5 times 2g, which is gravitational acceleration. So we have 2 times 9.81 meters per square second. And this is also meter. So V2 will be equal to 9.9 meter per second. So this is the first finding from this system. So we need to find the discharge in the pipe, so that it means we need to find the flow rate. And from continuity equation, you will remember that the Q, which is flow rate, is equal to V times A, which is velocity times area. And when we look at the area, we will need to take this diameter, because we are going to calculate flow rate here. So we have 9.9 times pi times 0.2 square over 4. And this is equal to 0.311 cubic meters per second flow rate. So this flow rate is actually same for this entire pipe system because there is no diameter change and there is no change in area. So that we will get same flow rate for the entire system. And now let's look at the second question, which is pressure at point B. And to do that, this time we can create another energy equation. This time it will be between surface and point B. So let's say point B here. So if you write it again, so again we have 0, we have 0. So we will take we will calculate Z1 minus ZB. So it is the distance from here to this level. So it will be 1.5. Or you can say this is 1.5 and this is 0 because it is the reference. And this time, of course, we will have pressure because this is inside the pipe and it is a full pipe. So it means we have a pressured pipe. So we cannot assume it is 0. So plus 0. Here, since we will have same flow rate for the entire system, so it is because we have 40 centimeters diameter along the pipe, so that and we have a discharge here, which we calculated as 0.311. So the flow rate here should be equal to the flow rate inside of the pipe. But this means since flow rate is equal to V times area, velocity times area, since area is changing and since diameter is changing, area will be changed. And this means we will have a different velocity at this point. So let me write that. VB is equal to Q over A. Q is 0.311 cubic meter per second. Area is pi times d square, which is 0.4 square over 4. So 4 centimeter diameter is this pipe's diameter. From here, VB will be equal to 2.48 meter per second. And we can use this number in this equation. So 1.5 is equal to PB over gamma plus 2.48. It's actually 2G. 2 çarpı 981 meter per square second. And this is meter per second. And this is V square. So we have PB over gamma, and we have V square over 2G. And on the left-hand side, we have 1.5. So this is 0.312 meters. We have 1.5 meters. So this means PB over gamma is equal to 1.5 minus 0.312. So since the specific weight is 9,810 Newton per cubic meter, we can calculate the pressure B as which gives 11,654 Pascal or 11.65 kilopascal. So this is pressure at point B, and this is the discharge we have. Okay, let's continue with a similar question. This is 7.23, and this is also using energy equation. Here we have a gasoline with a specific gravity of 0.8, and it is flowing with a rate of 5 cubic feet per second. We need to find the pressure at section 2, which is here, when the pressure at section 1 is 18 pounds per square inch, and the head loss is 9 feet between these two sections, and the coefficient is 1. So here the points are already given as 1 and 2. And here you should be careful about their locations. They are actually inside of the pipe, even if 2 looks very close to the outlet. It is sitting inside of the pipe, so that we will have pressure at both of these locations. So let's get started. First of all, we can start the solution with finding velocities. So the flow rate is 5 cubic feet per second. So using content equation, we can get the velocity at point 1. So we have 5 cubic feet per second, and the area is given as 0.8 square feet. This makes 6.25 feet per second at point 1. And for second velocity at point 2, we have Q over A2. Again, the Q is 5. Because of the content equation, we will have same flow rate, but because of the changing area, we will have different velocities. And 0.2 is coming from area, so that we have 25 feet per second. Since we actually need V1 square over 2G and V2 square over 2G, we can actually calculate them. So we have 6.25 square over 32.2 feet per second square. So this is 0.6166 feet. And when we do V2 square over 2G, This is 25 over 2g. So here we will get 9.705 feet. So this is the energy equation, but this time we have head loss, which is written on the right hand side. This is because the energy is higher at this point, and it is getting lower due to head loss. So from energy equation, we have P1 over gamma plus V1 square over 2g, 0.6 feet, and we have Z1. So we can take this point as 0, and this will be 12 feet. So we have 12. This is equal to P2 over gamma plus 9.705 feet plus 0. And finally, since we have head loss, we will have 9 feet. So let's look at P1. It is given as 18 pounds per square inch. It's actually pound force per square inch. And since all other units are in feet, we can actually convert it to feet. And the specific weight is 62.4 times, since this is not water, this is gasoline, we are going to use 0.8 as the specific gravity. So we have 0.066 plus 12. So here only unknown is P2. So writing 0.8 times 62.4, we can get P2 as 2,287 pounds per square feet. And this is actually coming from 15.9 PSIG. So I didn't directly do these conversions, but inside of the equation, you can do that like we did here. This is question 7.25. Here we have a reservoir with water is pressurized here. So even though we took this point as reference, it will the pressure is not 0 because it is under pressure. The pipe diameter is 1 inch and the head loss in the system is 5V square over 2G. The height between the water surface and the pipe outlet is 10 feet and the discharge is going to be 0.1 cubic feet per second. So we need to find the pressure in the tank to be achieve such a flow rate. So D is 1 inch, which is 1.12 feet. So again, we have an energy equation and we have head loss on the right hand side. Here we cannot discard P1 because it is under pressure right now, but we can still assume velocity is 0 because it is the surface of this tank, so the velocity will be negligible. And when we look at right side, we can still assume the pressure is 0 because the question clearly says that we are taking outlet. So since this is the outlet, we will have water flowing to the atmosphere, so we will have 0 pressure. So let me write this is 2 and this is 1. And of course we will have velocity because the water is flowing with this velocity. And also, since we can take this point as reference as 0 point, we can take z1 as 10 feet. And we have p1 over gamma plus 10 feet. This is equal to v2 square over 2g plus 5v square over 2g. Let me check it again. Yes. So let's first find v2 here. v2 is q over area, and q is 0.1 cubic feet per second. We have the area pi times d square over 4. And from here, v2 is equal to 18.33 feet per second. So here we actually have 6v2 square over 2g, because the velocity along the system will be equal to velocity at v2, because diameter is same here, same, and it is same for the entire pipe, so that we have v, or we can say v2. So we can find this calculation, or let me directly do solution. So we have p1 over gamma equal to 6 times 18.33 square over 2g, which is 2 times 32.2. And we have minus 10 from here. This gives 21.3 feet. So P1 is equal to 62.4 pound-force per cubic feet times 21.3 feet, so that we can get 1,229 psfg pound per feet inch, or it is equal to 9.23 psig. This is question for 7.30. Here we have a discharge in the siphon as 2.5 cubic feet per second. We have diameter as 7 inch, and we have L1 and L2. So L1 is 4 feet and L2 is 5 feet. And the diameter is 7 inch for the entire pipe. Determine the head loss between the reservoir surface and point C. So this is the first thing we need to find, head loss between the reservoir surface and point C. So let me write, let's say this is 1 and here's outlet C. And we need to find the pressure at point B if 2/4 of the head loss occurs between the reservoir surface and point B. So this means we have a head loss for the entire system, but 3/4 of the head loss is happening between these 2 points. So let's get started. Again, we will need to write energy equation, and let me directly use this one. These are actually C, so let me write C. And we will have head loss. So let's start with estimating some values. So first of all, the point 1 is open to atmosphere, so we will have 0 pressure. And since it is the water surface, we will have 0 velocity. The Z1 will be 5 feet because it is between C and surface, which is L2. And here we will have 0 pressure because this is the actual discharge, so water is opening to atmosphere. But we will have Vc square over 2G. And since this is the reference, we will have 0 feet, and we have head loss. So here we can actually calculate the velocity of C. It is because we already know the flow rate, which is 2.5 cubic feet per second. And the area is pi times d square, which is in inch, but we will convert it to feet. Over 4. So from here, Vc will be 9.35 feet per second. And if we use this value here, head loss will be equal to 5 feet minus 9.5 square over 2 times 32.2 feet per second square. So this gives head loss as 3.64 feet. So this is the first thing that the question asked. So we calculated the head loss. And now we need to find the pressure at point B. We can write the equation between point B and this surface. Get an equation between 1 and B. This level and this level. So again, these are 0. Let me use red. This is 0. And here, if we take this level as the reference, Z1 will be 0 as well. So ZB will be this L1, which is 4 feet. So we have 0 is equal to PB over gamma plus BB square over 2G. And since the question says the head loss between these two sections is 3/4 of the total head loss, we will have something like this. 3/4 times head loss. So we actually know VB because the flow rate will be same for among the throughout the pipe, and since the diameter is same at this point and also at this point, VB is actually equal to VC. So this means PB over gamma plus 9.35 V square. We have 2G, again 2.32.2 feet over square second plus 3/4 times 364 feet. And one thing also, we have specific weight, which is 62.4 pound per cubic feet. So this means we know all of the values except PV, which is the actual solution. So from here, when you do all the calculations, you'll get PB over gamma as minus 8.01 feet, and PB is actually equal to minus 505 PSF or minus 3.51 PSI. This is question 7.31, and we have another siphon here. We have elevations at A, B, C, and D as given, and the head loss between the inlet and point B is 3/4 of the velocity head. So this means between this water surface and point B, we have head loss, which is 3/4 of velocity head, which is V square over 2G. And the head loss in the pipe itself between point B and end of the pipe is 1/4 of the velocity head. So this means from B to D, we have 1/4 V square over 2G. And for these conditions, what is the discharge and what is the pressure at point B? The pipe diameter is 25 centimeters. So here we can again write energy equations, and I would like to pick point A and surface of this lower reservoir, let's say C. So let's write the energy equation again. Let me use A and C. And the head loss. So we have zero pressure at A, zero velocity again, and the A, which is here, is 30 meters. This is equal to PC. Again, since we take this water surface, the pressure is zero and the velocity is also zero. And here you should be careful. We are not picking a point here, but we took water surface. This is actually easier because we are dealing with these two water surfaces. This means we will have zero pressure, zero velocity. So it makes calculations easier. So we have zero velocity, zero pressure, and the elevation at C is 27 meters. Here we are going to use head loss. So let's look at what the question says. Question says we have 3/4 of velocity and 1/4 of velocity head loss. So this means we have a total, we have a total 1 velocity head loss within the pipe. And another thing is, since this is the exit, we will also have another head loss at outlet, and this will be this actually not V, yeah, and this will be V2 square over 2G. So this is actually exit head loss or outlet head loss. You can call it either way. So let's say V2 over 2G again. So this makes we have two velocity head loss. Here the basic idea is the water is leaving the pipe at point D, and then it is actually flowing through the sea. So this means we are coming to that way. So this means we can actually consider the head loss within this entire pipe plus the head loss at this exit, so that we have two velocity head as the head loss. And since the water is again coming here, we can directly use this point as the second point, and we can take this total head loss, which is pipe head loss plus exit loss. So actually let me write this. This is exit and this is pipe head loss. So we directly used Vp, which is the velocity within the pipe, because the diameter is constant, so that we will have same velocity even at the outlet or even in the pipe. So this means velocity within the pipe is 5.42 meter per second. And this gives us the flow rate within this pipe. So we have 5.42 meter per second times area. We have pi times, we have 25 centimeter diameter. So this gives flow rate as 0.266 cubic meters per second. And the second question is finding the pressure at point B, so that we can actually write an energy equation between A and B. So let me write energy equation A and B. So we have PA gamma and the head loss. So we have zero pressure, zero velocity at A, but of course we will have pressure and velocity within pipe at point B. And the A is actually 30 meters. This is equal to PB over gamma plus the velocity at B. So again, since we already calculated the velocity within the pipe as Vp, it will be same at this point as well. So let me write 5.42 square over 2g. And we can also write this, which is specific weight, plus the elevation of B is 32 meters, plus we have 3/4 of velocity head as the head loss. So it is 3 or 4. So since it is velocity head, we are again using the Vp, which is velocity within the pipe. So 3/4 of velocity head gives this. And from this equation, PB will be minus 45.3 kilopascals. Okay, this is the final question, question 6, and it is 7.40. Here we have water discharge as 8 cubic meter per second, and it is flowing through this horizontal pipe, and the diameter is 1 meter. The head loss in the system is given as 7 velocity head, and V is of course velocity in the pipe. How much power will have to be supplied to the flow by the pump to produce this discharge? And we will assume the coefficient is as 1. So let me write the complete energy equation, which means we will also include the head of pump, the head loss, and turbine. And if we had a different value of alpha, it would be used here. and we have turbine and we have head loss on the right hand side. So we can take this point as point 1 and again outlet as point 2. This is usually ideal because when we take reference water surface as 1 point, we will discard pressure and velocity. And it's the same for the outlet because we will not have pressures and we can calculate flow conditions at the outlet using given values. So we have zero pressure, zero velocity. Z1 is 40. And this time we will have HP, which is the head provided by pump. So this means when we use this pump, for example, it will increase the water this much, and this will be called as HP. So P2 is also 0, and we will have V2 square over 2G, and Z2 is 20. We don't have in turbine, so and we have head loss, which is 7 velocity head. So here we can calculate the velocity because we already know the flow rate is 8 cubic meter per second, and the velocity will be 8 cubic meter per second divided by the area, and the area is 1 meter, so we have pi 1 meter square over 4. So the velocity is 10.2 meter per second. And if you go back to this equation, we have 40 meters plus head pump's head equal to 10.2 square over 2G plus 7 10.2 square over 2G. And G is 9.81 meter per square second. And from here, the head provided by the pump will be equal to, we also had 20 here. So HP will be equal to 22.4 meters. So the question asks actually the power, and power is calculated by flow rate times specific weight times head pump, or pump head by the pump. So we have 8 cubic meter per second. We will have specific weight times HP, 22.4 meters. And from here we will get 1.76 megawatts.